Hello everyone. In today's video, I will discuss and then solve the 10th challenge of Damn Vulnerable Defi, FreeRider. Check the timestamps in the description below to see when I go over the solution if you want to try to solve this challenge on your own. As always, I will be analyzing the contracts that make up this challenge initially, then go over my solution. A new marketplace of damn valuable NFTs has been released. There's been an initial mint of 6 NFTs, which are available for sale in the marketplace, each one at 15 ETH. A buyer has shared with you a secret alpha. The marketplace is vulnerable and all tokens can be taken. Yet the buyer doesn't know how to do it, so it's offering a payout of 45 ETH for whoever is willing to take the NFTs out and send them their way. You want to build some rep with this buyer, so you've agreed with the plan. Sadly, you only have 0.5 ETH in balance. If only there was a place where you could get free ETH, at least for an instant. So, let's take a look at the two primary smart contracts that make up this challenge. The FreeRiderNFTMarketplace contract, and then the FreeRiderBuyer contract. The marketplace constructor deploys a damn valuable NFT contract, then mints the amount of NFTs passed to the amount to mint argument, setting the owner as a deployer for each minted token. The offerMany function takes as input an array of token IDs and an array of corresponding prices. This function allows the owner of any of the tokens to set an offer price in Ether for each of them. It first checks to make sure that the token ID array length is greater than 0 and equal to the prices array length. It then loops through the corresponding elements in the arrays, passing each of them as inputs to the offerOne private function. The offerOne private function checks that the price is greater than 0, then ensures that the account that called the function is the owner of the token and has approved this marketplace contract to transfer their tokens. The price of the token is then stored in the offers mapping and the amount of offers variable is incremented. The buyMany function is the other external function within this contract and allows anyone to buy tokens offered by the seller. The function is payable and takes as input an array of token IDs and loops through it, passing each ID as inputs to the buyOne private function. This function retrieves the offer price of the tokens by passing its ID to the offers mapping and assigning it to the price to pay local variable. It then checks that an offer has been set for the token by ensuring the price to pay is not 0. It also makes sure that the Ether amount sent with the buyMany function is enough to cover the price of the token. Lastly, the amount of offers variable is decremented. The token is transferred from the seller to buyer, and the seller is paid the offer price. Now that I've walked you through the marketplace contract, let's go through the buyer contract. Inside the payable constructor, the buyer is required to send the payout amount of 45 Ether with the deployment of this contract. Next, the partner and NFT contract variables are initialized, and the NFT's set approval for all function is called, which allows the buyer to transfer the NFTs owned from this contract to their account. The onERC721 received function is a special function that's triggered whenever an NFT is sent to this contract or any other contract. The function checks that the NFT contract called the function and that the caller who originated the transaction is the partner. It also checks that the token ID is a non-negative integer less than or equal to 5. And that the owner of the NFT is this address. Lastly, the receive variable is incremented and the partner receives their payout once all the NFTs has been transferred over. If you want to take a crack at solving this challenge, I highly recommend that you check out the Uniswap V2 docs and OpenZeppelin's ERC721 NFT standard docs. Links to both these resources will be in the description down below. Alright, pause the video now, try to solve it, and come back once you are ready to see the solution. Here's the solution. There are two vulnerabilities inside these buy functions. Specifically, this require statement checks if the buyer sent enough Ether to purchase only the most expensive NFT referenced in the token's ID array, not the running total cost of the NFTs. Also, this line of code does not pay the seller. It pays the buyer because it sends the payment to the address of the owner of the NFT after transferring ownership from the seller to the buyer. Now, in order to drain the marketplace of all its NFTs, we can utilize a flash swap to loan the amount of ETH we need to purchase the most expensive NFT on the marketplace, which in this case is only 15 ETH. But we have to pay this amount back in the same transaction. So how do we do this? To do this, we would have to deploy a malicious contract that contains a function that we can call to do everything we needed to do in a single transaction. And that's what this attack FreeRider contract does. In the constructor, we initialize the pair, marketplace, buy contract, and NFT contracts, as well as the attacker and WETH addresses. This attack function executes the swap function of the DVD to WETH pair contract, passing as input the amount of WETH we are flash swapping from the DVD to WETH pool, the amount of DVT we are flash swapping, which is 0, and the recipient of the loan, which is this address. Now, in order for this pair contract to recognize a swap as a flash swap, we have to pass in some arbitrary bytes data as a fourth argument. Once the swap function is called on the pair contract will call the Uniswap V2 function specified here on the recipient address, which is this contract. This function first checks that the caller is a pair contract and the contract that sent the swap is this contract. Then it unwraps the WETH by calling the withdraw function on the WETH contract. Now, if we want this contract to accept the ETH sent to it from the WETH contract, we need to declare a payable receive function down here. Now that this contract has the ETH it needs to drain the marketplace, we can call this buy many function on the marketplace contract, passing in the array of all token IDs in the marketplace and sending the borrowed ETH. But according to the ERC 721 standards, if we want this contract to be able to accept the NFTs sent to it, we have to declare this on ERC 721 received function. All this function does is check that the caller is the NFT contract and the transaction originator is the attacker. Once all the NFTs has been sent this way, we can calculate the repay amount, which is equal to the loan amount plus a small fee. And the small fee is about 0.3% of the loan. Since we have to pay back the loan in WETH, we wrap our ETH by sending the repay amount with our call to the WETH deposit function, then transferring the same amount to the pair contract. Now that this Uniswap V2 function has finished executing, we can now transfer all the NFTs to the buy contract by calling the safe transfer from function on the NFT contract for each of the token IDs in the token ID array. Finally, we can transfer the ETH that this malicious contract collected from both the marketplace and buy contract using the low-level call function and checking to make sure the transaction was successful. All that's left for us to do now is to deploy this contract, then call its attack function within this FreeRider challenge script file. We pass the NFT price to the attack function, then fetch the attacker's ETH balance and log that value to the console. All right, let's run the exploit. Sweet. And as you can see, the attacker's ETH balance is roughly equal to 120, which is what we should expect since the attacking contract spent 15 ETH and received 90 plus 45 ETH from the marketplace and buy contract respectively. If you do the math, that should equal 120 net ETH. Alright, that's all I've got for today's video. If you found it helpful and you'd like to see me produce more Web3, DeFi, and/or Ethereum development content, leave a like and subscribe. It helps the channel out a lot. Until next time.